Hello everybody, myself Jyoti. This is second lecture on field effect transistors. So in the last lecture we discussed about introduction of the JFET, that is junction field effect transistor, and also we discussed about the constructional details of JFET. In today's lecture we will discuss about the principle and working of JFET. So first let us talk about the principle. So JFET, it works on the simple principle that the resistance of the conducting channel, it depends upon the reverse gate voltage. Or if we want to talk in terms of current, we can say that the drain current which is flowing through the conducting channel, that can be varied by changing the reverse gate voltage. So this is the basic principle of JFET. Now let's check how does it work. So let's see the explanation for that. So today we will see the working of JFET. So यहाँ पे you can see this diagram of N channel JFET. Here this is an N channel, N type bar, and we have two PN junctions at the two sides. Now these two PN junctions which are there, they form two depletion layers. Now the current conduction by charge carriers is through the channel between the two depletion layers and out of the drain. So here charges are moving from source to drain. And here the width and hence what we can say is the resistance of this particular JFET, it can be controlled by changing the value of input voltage VGS. So here this is a P-type region and I have applied negative voltage to this P-type. That means that I have applied reverse voltage. The greater the reverse voltage VGS, the wider will be the depletion layers. This depletion layer will increase and narrower will be the conducting channel. The narrower conducting channel means greater resistance and hence source to drain current decreases. So here if I apply more and more reverse voltage, depletion layer is increasing. That is how width of the conducting channel is reducing, and that is how the drain current also reduces. When a voltage VDS is applied, here there is a voltage which is applied between drain and source. When we apply this VDS between drain and source terminals, and suppose I haven't applied any VGS, I have kept the switch open, that means I haven't applied any VGS yet, or we can say the voltage on the gate, it is 0. The two PN junctions at the sides of the bar establish depletion layers and the electrons will flow from source to drain through a channel between the layers. The size of this layer determines the width of the channel and hence current conduction through the bar. So when we apply more and more reverse voltage, then the width will, the depletion layer's width will increase, the width of the conducting channel will reduce and hence the drain current will reduce. Now here this JFET, it is also called as field effect transistor. So why JFET is called as field effect transistor? Now here we know that the current from source to drain can be controlled by the application of potential. So here we are talking basically about the electric field. So source to drain current we are controlling by the application of potential, that is electric field. And for this simple reason, the device is called as FET or FET. Second important question here is what will happen if the reverse voltage VGS on the gate is continuously increased. Suppose we keep on increasing the reverse voltage VGS on the gate, then a state is reached when the two depletion layers touch each other and the channel is cut off, and under such conditions the channel becomes a non-conductor. So here I have given the symbol of JFET. This is drain terminal, source terminal, gate terminal. For N channel JFET, the arrow is inward. And for P channel JFET, again the symbol is same, only the arrow is going down, outside. Okay. So now the main topic is, let us see the difference between JFET and bipolar junction transistor or the ordinary transistor. So we have seen that in a JFET there is only one type of carrier that takes part in the conduction process. So either holes in p type and electrons in n type. So that is how we call JFET as a unipolar in nature. In BJT, both holes and electrons, they play part in conduction, and that is how it is called as bipolar transistor. Second important difference between the two is input circuit of JFET is reverse biased. So we know that when it is reverse biased, the resistance will be high, and that is how the device has high input impedance or high resistance. But in case of ordinary transistor, input circuit, it is forward biased, and hence it has low input impedance. Third important difference is no current enters the gate of JFET, that is IG gate current, it is 0. But in case of BJT, base current might be of a few microampere. It is very less value, but it is of the order of few microampere. But in case of JFET, gate current is 1000 times smaller. JFET uses voltage on the gate, that is base terminal, to control the current between drain and source. So here I have compared gate with base, drain with collector, source with emitter. So JFET uses voltage on the gate terminal to control the current between drain and source, and BJT uses a current into its base to convert large current between collector and emitter. JFET gain is characterized as transconductance, that is the ratio of change in output current to the input voltage. So, and in BJT it is characterized by current gain. So that is all about the working of JFET.